Alright, we are going to have a look at something called the uniform convergence criterion. Now, we have very few assumptions. The only thing we assume is that functions labeled fn and function f are all functions mapping some interval j onto the real number line. Then we claim fn converge uniformly to f on j if and only if the limit as n approaches infinity of the supremum of the difference fn x and f of x on j is equal to 0. In other words, if this is a vanishing function. Now, the proof is trivial. So, proof. By definition, if fn converge uniformly to f, this means that for all epsilon greater than 0, there exists some capital N natural for all n greater or equal to capital N for all x from j, such that f of n of x minus f of x is smaller or equal to epsilon. This is nothing more, of course, than the very definition of a uniform convergence. But we can observe that this is actually equivalent to the following expression. This is the same as saying that for all epsilon greater than 0, there exists some capital N natural for all n greater or equal to capital N. And now, instead of putting there for all x in j, we can say that the supremum over all x in j of the difference fn of x and f of x is smaller or equal to epsilon. But of course, this is the very definition of a limit. So this is the same as saying that the limit as n approaches infinity of the supremum x in j of the difference fn of x and f of x is 0, which is precisely what we wanted.